Hello, everyone, and welcome to this product demonstration webinar, Transform Your Quality Process, brought to you by HiQA. I'm Lisa Sterling, your host and moderator for today's session. Before we get started, though, I would like to mention just a couple of housekeeping items. We invite you to ask questions throughout the presentation by typing into your Q&A tab at the bottom of your screen, as your phone is muted throughout the session. We will address the questions received at the end of the presentation. Please note that this webinar is being recorded and will be available for playback in a few days. I would now like to introduce you to our presenter, Ryan Ganser, Regional Sales Director at HiQA. And with that, I will turn the floor over to Ryan to get us started.
Thanks, Lisa. All right. So before we jump into the demonstration itself, I do want to just provide some additional education on who HiQA is, what we do, and how our customers are utilizing HiQA. Specifically, in the demonstration itself, we'll talk about and show how we can plan a job 5 times faster with auto ballooning. I would argue that that number might be closer to 10. I think a lot of our customers would as well. But we'll also show from a data collection perspective how we can automate and speed up that analysis by oftentimes 75% or more, whether that be coming from your manual checks, your calipers, mics, stuff like that, or your automated measurement devices, your CMMs, VMMs, ferro arms. The idea with HiQA is doing everything in one spot inside the database in an automated fashion. Lastly, we'll touch on how we can create reports, such as your first articles or full-on submission packages. Everything is going to be templatized in the system. So with these 3 bullet points, you can think of it as we're automatically bringing in the requirements to the database through the auto ballooning functionality. We're automating data collection, whether that be out on the shop floor or from your CMMs, bringing that into the database. And then we're templatizing all of your various reports, where you'll hear me say it a couple of times. You're able to automate downstream, ultimately providing these reports for your customers. A little bit about HiQA. We're currently we have over 1,300 customers. We are a global company on 5 different continents, and we have over 20,000 users worldwide. Plans and customers range completely from large OEMs to 1- and 2-person shops. So there's a lot of flexibility, not only in the product itself, but also in terms of plans to match the needs, budget, and functionality required for each individual company. We're also very heavily concerned with data security and collaboration. The bulk of our customers are in the defense, medical, aerospace, automotive, and industries that care about that security. The main thing to note is we are fully ITAR compliant, not leaving your network throughout various installations. Lastly, a very customer-driven culture. Hopefully in today's demonstration, you'll get an idea of how configurable the platform is, designed to increase the efficiency of your manufacturing processes. By no means is it a plug-and-play software, so there's a lot of flexibility and configuration options that have been as a result of customer feedback. So lastly, before we jump into the product itself, this image over here on the left-hand side, it's a good image to kind of articulate and visualize everything that can be done inside of HiQA. We're an all-in-one database-driven solution. So whether that's job and part planning, production and data collection, your reporting and submissions, or even supplier collaboration, all of that is done inside of the HiQA database. So eliminating siloed areas of information, whether that's the quality department, the manufacturing operations department, everybody's doing their processes inside of the HiQA database, eliminating any, interpretation inefficiencies. Also being database driven, once it's done, everything saves in real time to the database and can be retrieved at any point down the road. Okay, So now we're going to jump into the demonstration itself. Here is HiQA. We are an on-premise solution. So as I mentioned earlier, primary customers are in the defense, aerospace, medical industries, right? So not leaving your network walls. I'm just going to bring in a PDF that I have saved on my desktop. All right. Simple machined part here, right? Not too much going on. Just know we can take on much more complicated drawings than what you see here. And as a recommended next step, we're more than happy to show you guys the system in greater detail, right? Today will be a pretty high level overview. So we'd be happy to show it in greater detail, but also with your own drawings, right? You know how long things take with your current drawings. Happy to show you that process. So simple machined part here. Like I said, you can move the print around, you can zoom in, you can zoom out just with your mouse. General layout, the system is designed to be very Microsoft-like in nature, in that ribbons are on the top, drop down arrows, all that good stuff. The first thing I'm going to do is I'm going to click Auto Balloon up here at the very top. This is where everything starts for us, is we want to get all the dimensions identified and extracted into the HiQA database. And you can see we do have different preferences here. So if you had like a multiple page packet, you could balloon all the pages at once. You could choose select pages to balloon, or just the current page that you're on. You can also tell the system, right, you don't care about basic, reference, or general tolerance dimensions, things like that. I'm just going to click OK. At this point, we're sending this print through our proprietary OCR technology. OCR, an acronym for optical character recognition. Essentially, we're scanning this print, identifying all the dimensions, and extracting them, including all GD&T, into the HiQA database. As I said, it is a proprietary technology. Literally took us 6 years to develop what you saw here in just 18 seconds. And you can see we're fully ballooned. Even more important, or I would say impressive, than ballooning all these dimensions is down below what we call our bill of characteristics. I'll drag it up here. This is everything that we extracted in that, I think it was 18 seconds. Essentially, here's your inspection plan, automatically created here for you, saved to the database. Just to highlight a couple of the features, we have the dimension number, dimension type, requirements. If there are any multipliers, we will auto recognize that. You can see here are these 4 X's. We can do some cool things with those. We'll get into that in a little bit. We're also extracting the nominals, the tolerances, all of this saved into the database in real time. So throughout this demonstration, you're never going to see me, save as or put something in a folder or anything like that. Everything saves in real time, the beauty of being database driven. In this system, we have what are called part categories. So I'm going to flip here to our part properties tab. And you can see up here at the very top, I'm under the part category Ganser machine. The easiest or quickest way to describe a part category is it's a series of defaults. So a series of defaults or preferences that all roll up into that part category, right? So most of our customers will have part categories for their customers or part types, part families, things like that. But again, it's just a series of defaults with the mindset of having things set up ahead of time as part of these part categories in such a way that you can automate things downstream. So a couple of factors into part categories. One is our sampling rule. So my system or my part category is set up to sample at 1 per lot. I mentioned it earlier, the highly configurability of the system like this. You can always change things after the fact as well, right? So if I wanted to click into the sampling rule, you can see I'm set up at X per lot with a value of 1. I can sample based on an AQL table, percent from lot size, per hour, per shift, per X. whatever I want. Again, it's set up ahead of time as part of my part category, but you could change if you wanted. Other aspects of a part category is our tolerance table. So if I click this tolerances tab, so we have different tables, decimal, range, surface finish, or fit tolerance tables to automatically apply default tolerancing. Now, if the or if the tolerance is called out on the print itself, so like our plus plus here, you can see over here to the right, just kind of general setup, this right-hand window, think of it as like a peek into the database, just shows you what the system comes up with. So talking about this plus plus tolerancing, you can see we will bring that in. But then if it's not on the print itself, so like this 4-inch, based on the number of decimal points, in this case, how my system is set up, we'll bring in plus or minus 10 thou. Additionally, when we're talking still about this part category topic, again, series of defaults, I have my system, when we're looking at this gauge category, I have my system set up so that if it's a linear, we're going to use a caliper. And now that's a category. That's not an individual caliper. It's the category of the gauge. Again, you can always change after the fact. Maybe I wanted to measure this with a mic and whatnot. Also in the system, we do have gauge management functionality, which ties in very nice when we're talking about data collection. So you can think of it as this way, as I automatically identify that we're going to use a caliper. We don't know which caliper yet. That ties into my gauge management tool, which ultimately streamlines out to the shop floor, letting the shop floor know, hey, you're going to use a caliper, but also here's your available non-expired calipers. And then lastly, by doing everything inside of HiQA, you have that traceability, that usage history for every gauge in the system. Okay, so now let's just look at the drawing itself here for a second. I'm going to focus in on our title block. So we're not pulling information from our title block with our auto ballooning strategically, but we can do some cool things with it if I flip to our part properties tab. You can see here part number, part name. By default, that's just the file name that I brought in, sample2 PDF. But I'm hovering over it now, this extract title block text icon. All of these different icons here in the top left, I call these efficiency tools. They're just ways of doing things more efficiently, more consistently than the typical manual process. We'll highlight a couple of them here today. The first, like I said, this extract title block text. So we're now leveraging that OCR technology in a couple of different ways. So I'm just going to box select this shaft clamp bracket. So I'm clicking, dragging, and once I drop, I can tell the system, all right, this is our part name. And then if you notice up here in the top right, that part name is now populated with that shaft clamp bracket that I captured, right? I'm not touching the keyboard. I'm not saving. Everything's saved in real time without manual work. We can do the same thing with our part number. You can see part number is now saved to the database. Any form that we eventually are going to populate that requires a part name or part number, that's going to automatically be populated with these fields that I just extracted. This rev I like to also point out because it is a different size and style text. So our OCR it's definitely our biggest claim to fame. Being able to recognize things of different size and style. It's second to none. Let's just say that. And at the end of the day, these are open text fields, so I could type this information in. But the goal of a system like that, this is to not have to do things like that. Okay, moving on. We talked about the tolerances, right? Where that's coming from down here, different tables, default tolerancing, based on, again, these part categories that we have set up ahead of time. So for those of you that balloon notes or are required to balloon notes, we're intentionally not going to auto balloon notes just because there's really no standard for that, right? They could be anywhere on the page. They could be required. They could be not. Um, but another efficiency tool we have, highlighting it now, is this T icon to balloon notes. When I click that, that flips our OCR so that we're no longer looking for GD and T anymore. We're just looking for text. So now, just as I did with the part name and part number, I'm box selecting. I'm clicking, I'm dragging, and I'm dropping. And once I drop, you might notice down below, as part of our inspection plan, we have balloons 25, 26, 27 as a note, right? And if you remember on the right-hand side, these are always open text fields. So you could type in whatever you like. This is my note. And this will show up on our inspection plan as like a pass-fail, for example. Also, we do have these automatic leader lines. So as things get a little condensed, you can clean things up. And everything you see here is configurable, right? Balloon size, balloon shape, colors, things like that. It's all, again, part of those part categories that we talked about. Okay. Next, I'm going to move on to our material. So just below the T to balloon notes, we have this M to balloon material. And pretty consistent with what I've done, we're box selecting, clicking, dragging, and dropping. Just to direct your attention to the right-hand side of the screen, we now automatically flip to our Materials and Processes tab. You can see the T6 that we captured. At any point, if you do see a pencil inside of the system, that gives you the opportunity to drill down or add more information. So if I click into this pencil, if I wanted to add like a material code, a spec number, a cert number, indicate who the supplier is, things like that, I can. And again, everything is saved to the database. Even more importantly, you can add attachment files. Most commonly here is like a material cert, for example. So again, we're going towards reporting, right? So now any report that requires a material cert is going to automatically show up. Okay. Moving on, let's look at this balloon 16. This one's interesting for a couple of reasons. For one, it's a stacked dimension, right? We have a diameter, a thread, and a true position. We also have a 4x for these 4 holes. So at the end of the day, there's really 12 lines of data, right? The 4 times 3. So this is where, again, there's a lot of configurability in the system. This is just how my system is set up. Down below, you can see it at 16.1, 0.2, and 0.3 for the diameter, thread, true position. We also have the 4x called out there. So for those of you that are required to balloon these separately, for example, like a 16 for the diameter, 17 for the thread, and an 18 for the true position, you can do that. When I originally clicked auto balloon, if I would have just had the split sub characteristics checked, it would have done exactly that. Additionally, if you wanted to explode or multiply these dimensions out, over here to the right, we have this multiply dimensions button. Now what that does, if you see down below, now all 12 lines are called out. 16.1 underscore 1, all the way down to 16.3 underscore 4. It's in the database either way. Essentially, we're just changing how we're viewing things at this point. And then on the drawing itself, we do have these automatic leader lines. So you can drag them over the individual holes if you wanted. Again, just however you want to view things, that's what we can do. Okay. For those of you that have to work in metric or flip between metric and English or vice versa, another efficiency tool we have up here in the top right or top left It's called show alternative units. One click of the button, I'm now in metric. Flip back, we're in English. Again, this tool is designed to be very collaborative in nature in that, hey, maybe you have a certain department or a certain customer that prefers metric over English or vice versa. Literally one click of the button. Now, just to kind of give you a little peek behind the scenes, it's not like we're doing the conversion with me clicking that button, right? In that first, I think it was 15 seconds of auto ballooning, we already did the conversion for every dimension. As I scroll over, you can see the metric there. So kind of like that multiplier, we're just changing the views on things. Okay. So this is obviously a pretty clean drawing, right? Some good resolution here. I don't want to give the expectation that we're going to be 100% accurate on all prints. It's just unrealistic. If it's something that's been scanned in 50 times from the 60s, there's only so much that the technology can do. So let's just kind of simulate that process of maybe we did miss something. So I'm going to just delete this dimension. Another efficiency tool we have, I'm hovering over it now, is called whiteout balloons. If I click that, that's going to hide every dimension that's already been captured, right? So now it's very obvious what still needs to be ballooned. So we now have this scissors icon appear in the top left, where I can just box select and grab this dimension. Click, drag, drop. Can double check what the system comes up with on the right-hand side, right? It's a 2-inch, it's a linear, based on the decimal points, plus or minus 10 thou. Based on the dimension type, going to use a caliper. We also have this reviewed checkbox. So like as a recommended best practice, double check what the system comes up with, take the whiteout off, and then you have this in the bottom left, this reviewed checkbox. So for example, maybe you're completing this part planning job, you get called away from your desk. It becomes very obvious, clear, and where you left off at this point. And then again, once you do this once, it lives in the database. This part record lives in the database. Some other functionality. For those of you that have to identify different levels of criticality, to designate different levels of criticality for your customers, like a key, or major, minor, or critical, you can build your own here. And this drives a lot of automation as well. So let's just say this was a CTQ, critical to quality. By me designating this as a CTQ, a couple of things happened. Again, these are part of these part categories, right? These preferences and defaults that I have set up ahead of time. Down below, you can see the CTQ called out. My system is set up to sample CTQs based on an AQL table, completely customizable. And then also on the drawing itself, my system is set up to move from a circle to a hexagon. Just visually, hey, this is critical. Something's different about here. Also, you're probably all noticing at this point that we're out of sequence, right? We're going from 11, 28 to 13. Just because I deleted it and then added it, it kind of goes to the end here. If I want to get these back in order, I just click numbering up here at the top. Now we're back in sequence. Okay. So now I do want to reserve some time for questions and ultimately answers at the end. So we're going to move pretty quickly, but we're going to touch on gauge management. We're going to break this part down into operations for like some in-process checks. And then we're going to get into the data collection side of things. We're going to go out to the shop floor for your manual checks. I'll simulate data coming from like a CMM. And then we'll get into the reporting side of things, whether that be a first article, a full-on PPAP with process flows, control plans, FMEAs, and things of that nature. All right, so up here at the top, I'm clicking measurement gauges. Here is kind of what you'd expect. It's a list of all your gauges. We do have different colors signaling different things. So like this kind of maroon, this thread plug gauge, signaling to me that it's approaching expiration. Looks like it expires next Friday on the 20th. And then in red itself, these are the gauges that actually have expired. We also have notification settings where you can be notified via email if a gauge is approaching expiration or has expired. You can put any email address that you want in here. It can be group emails, it can be your third party calibration vendor, whatever you'd like. Again, going to automatically send out these alerts. And then down below, just general gauge information, right? Here's our caliper 2. It belongs to the gauge category of caliper. Here's where it's located, and here's calibration details. The big benefit, or one of the big benefits of using our gauge management system is communicating and streamlining out to the shop floor. Again, based on that gauge category, we can let them know, hey, you need to use a caliper, for example. Then they can digitally check in, check out those gauges, enter in the results, where you'll ultimately have this usage history. So for this specific gauge, this caliper 2, I know every part, job, lot, dimension that's been measured. I know who measured them. I know when they made the measurements. Again, from a traceability standpoint, a lot of benefits of doing everything in one spot. Okay, so now that we talked about gauge management, we're going to break this part down into operations or those in-process checks that I had mentioned. To do so, I'm going to click this Manufacturing Operations tab. So if I want to assign certain dimensions to an operation, I can just hold Control and click the dimensions of interest. So these kind of overall dimensions here. And then I'm going to over here to the right-hand side, I'm clicking Add Operation. So now we have Op 10 in yellow, still tied to the original, the finished part, right, in green. It's just sub Op 10. If I wanted to add more at once, I can just box select, grab in bulk. So if I wanted to get these holes down here to the left, same thing, add operation. And then we'll just do one more to make it look pretty. Now we have Op 20, Op 10, Op 20, Op 30. Again, we have these pencils, right? So we can drill in, add more information. I can rename the op. Let's just say this is going to be our roughing pass. I can tie it to a work cell, a machine, a process. This can come from your ERP as well through an integration. But by identifying our process, we're now, if for those of you that are required to submit PPAPs or APQP submission packages, we're building your process flow, your control plans, your FMEAs at the part planning stage. So just to kind of breeze through this, maybe these were some holes. So we'll call this our drilling, tied to the drilling process. And then tied to turning process. Different colors, right? As you can probably imagine, completely customizable. But we have a print with our various operations on them. You can filter by those operations. So if I wanted to look at just roughing, I now have a print just for our roughing op. I can send this out as a PDF. I can send it out as an Excel inspection plan. Maybe before doing any of that, I want to update our requirements. Because again, these requirements, these are for the finished part. If this is our roughing pass, I can select all here and click bulk update. Oops, not sure what that was about. So we're bulk updating here. So we're changing these requirements, but only for our roughing op in this case. So if we're looking at the nominal, I can add, subtract, multiply, or increase by a percentage. Let's just say this is our roughing pass. We're going to add 20 thou, change tolerance to plus 50, I don't know, minus 40, things like that. I can also change how we're going to sample. I can tell the system that we want to monitor these dimensions for SPC in real time as the data is coming in. But again, all of this updates are just for, in our case, the roughing operation. And you can see down below, right? We added 20 thou plus 50 minus 40. Okay, so now that we have this part planned how we want to, we're going to get into the data collection side of things. First, as I said, I'm going to go out to our shop floor interface for like your manual checks. Then I'll simulate data coming from a CMM, and then we'll get into the reporting side of things. So this is our shop floor interface. Much more lightweight than what you've seen thus far. Can be run on like iPads, tablets, or just lightweight computers out on the shop floor. It is browser based, but we're still not leaving your network. So not web based or anything like that, where you can just log in. We can also, if your employees have barcodes on badges, they can scan in. And this would be something that they would see. Again, looks very similar to what we've seen thus far. A little tolerance bar down below. So doing the math for them on what's in and out of tolerance. Different operations, right? Our finished roughing, drilling, and turning. Let's just look at the roughing because that's kind of what we were playing around with. So if I'm assigned to the roughing operation, I'm not being confused with all these other dimensions that aren't a part of my operation, right? It's only the roughing op, where you can see the updated requirements, right? 0.52 plus 50 minus 40, gonna use a caliper. Now, when I go to select my tool and gauge, this is where that gauge management comes in and streamlining out to them, hey, you're using a caliper. Here's your available non-expired calipers, right? Just to show you, you can see I got some expired calipers here. Check out my caliper 2, enter in my results. We do support Bluetooth gauges or wireless connectivity. That's why this measured result box is blinking at me. So if you have those, we do support that. As I'm doing here, I'm just typing in the result, hit accept. A good check turned green and auto toggles to the next dimension. I'll do it one more time. A good check turns green, auto toggles to the next. Now, I am actually typing, right? I mean, I'm manually typing in the results here. So there's the potential for human error. Let's just pretend I accidentally typed in 40. I'll get a little message that pops up saying, hey, this is out of tolerance. Do you want to measure it again? Say, yeah, my bad. I fat fingered it. Need to measure it again. Adjust the value, or no, this is a failed check. And I want to keep it failed. If I click keep failed, we now have the option to populate an NCR, a nonconformance. And we're doing this at the point of failure, right? And since I'm doing it all in one spot, all of this information is already automatically populated. I know the job, I know the inspector, I know the time, I know the lot. We just auto serialize an NCR number and click OK. And this is where we would set up your specific defect types and defect codes, providing a little legend here as well, letting the folks out on the shop floor know what each code means. Again, promoting that consistency in how you're labeling things, ultimately giving you the option to run reports against your defect codes. Now we have an NCR tied to this dimension at this operation. We also, it turns red for a failed check. Now, if it were like a pass fail, it would look something like this. If it was an attribute, a visual check, even a note, for example, pass fail. So in a high level, that's the shop floor interface designed to be very lightweight, right? It's just instead of, the typical handwriting the results, rewriting it or retyping it into your Excel sheet, This is just all done in a digital format, flowing automatically back into the main system against the requirements that we've already established, the balloons. Okay, so now we're going to simulate data coming from a CMM, for example. So in short, we're installed on your network. In short, we have folders that we set up on your network from each of your automated measurement devices, CMM, VMM, FarrowArm, it doesn't matter. If it runs on software, they have the ability to export like a CSV file, for example, and we map it from your machines to those folders that we create on your network. And then we set up HiQA to listen to those folders. Every time that folder gets populated, HiQA is bringing those results in real time as a background running operation. Now, that is something that our onboarding team will set up for you as part of implementation. I'm just going to simulate that process, right? It's fully automated in the background, so it's kind of tough to actually simulate that. So I'm just going to import a static file. So up here at the top, I'm clicking import results from file, and then it's just a CSV file. I'll even open it up just to kind of show you guys what it looks like. So might look pretty similar to your CMM out exports that you're currently able to do. Again, the translations and setup, that's all something that we will do for you. The main thing is this actual column, right? We have actual results here. This is what I'm going to import. So that's the file I'm going to import. Red is bad, right? Just as we saw in the shop floor interface. Green is good. Gray means not yet measured. So you can see we got 3 dimensions here. First one, the diameter is passed. This next one, which is gray, this is our thread. This is where I can enter in, all right, that's a failed. This is the gauge I used. And down below, here are all of our results. Okay, so just to kind of recap, we planned the part and job, got it set up for in-process inspections. We touched on some gauge management side of things, which ultimately led us out to the shop floor for data collection for your manual checks from like a caliper, I think is what we used, a caliper. And then we simulated a CMM import coming in fully automated in the background. We now have results, so we're ready to report. If I only had to do a first article, I would just up here at the top click inspection reports. Now we have a single piece, multi-piece. I'm just going to click single piece. Your forms that you probably already have set up, those are what we're going to implement as a template inside the system. So AS9102, Net Inspect, for example, some of the more common ones that we deal with. I'm just going to click AS9102, Rev C. But again, we're establishing your forms, we're templatizing everything. And since everything's templatized and we have the requirements and results, just click a couple buttons and your report is automatically generated. And here, again, is just the AS9102. This would be your logo. This is form 1 with the part name, part numbers, all that stuff we captured at the beginning. Form 2, right, with the material, spec, the cert number, the supplier. And here's form 3 with all of your results. A lot of people like that we have these symbols automatically populated, little color indicating whether it's a pass or fail. If you remember, we identified dimension 12 as a CTQ. Now, if that file I imported had the tooling used, this column would be populated. This dimension was the one that thread that I put in kind of towards the end there. And there's your AS9102. So the same concept applies for like submission packages, right? Again, when we talk about these part categories, series of defaults and preferences, that can be customer, part family, part type specific, we templatize all of the forms and we just auto-populate. So I'm going to bring in a different part, but it's the same concept, right? Where I ballooned it, I created operations over here to the right, size cut, drilling, turning, milling, and finish. I tied those operations to a process. And then if I go to this PQP records, this submission package literally gets automatically populated because everything's templatized and set up as part of my part categories and my process library. So if we were to jump in and show a couple things, just to kind of paint the picture, this, what we call an index, is a series of documents. My process flow, FMEA, control plan, first article, gauge R&R. This customer specifically wants these documents. Have multiple indexes. There's an unlimited amount of indexes. If I just jump in here, let's just click on the process flow. This is where everything kind of starts to tie together based on the processes that I identified. Each one of these documents does have a digital workflow associated to it, which are completely customizable. You indicate who's involved at each stage, what happens when they submit, sign, accept, decline, email notifications, e-signatures, all that good stuff from a workflow perspective. Also, these documents are individual serialized and linked to one another. So for example, an auditor comes in, hey, you changed your process flow. Why did your control plan not change? It's with a system like this, that's literally impossible because they're linked to one another. Same thing with the FMEA. If I click in here, you can see, again, based on my processes that we've identified and the process library of failure modes, all this information completely editable as well, right? It's that mindset of have things set up, automatically create them, but also give you the ability to adjust after the fact as well. Control plan, AS9102, gauge R&R. Again, everything's templatized. We're at 25% progress because this is a 4-stage workflow. We're currently at stage 1. As it moves through the workflow, you'd get this to 100%. You'd click create or build final package, creates one single PDF document. It's ready to send out to your customer. So from a high level perspective, that's what we wanted to accomplish today, showing you the part and job planning, the auto ballooning inspection plans, moving on to the data collection side of things from an in-process perspective or final piece perspective, and then reporting against those requirements and results. So I did want to leave a couple minutes for Q&A. So Lisa, I will pass it back to you. And if you had any questions, I'm happy to answer them.
Okay, perfect. Thank you so much. Let's take a look at what questions we've received. And again, just a reminder, now is the time you can go ahead and type into the bottom of your screen where you see Q&A or the chat icons there. We did get a couple of questions come in while Ryan was presenting, so let's go ahead and get started. The first one says, where are you getting tolerances from if the dimension doesn't have a tolerance?
Okay. Yeah. So if the dimension has the tolerance itself, let me pull that print that we were looking at most of the time today. If the dimension or if the print has the tolerancing on it itself, so like this plus plus, we will bring that in. If it's not on the tolerance or on the dimension, this plus or minus 10 thou, that's coming ultimately from these part categories that I keep referencing, which again is a series of defaults and preferences. So to show, because if you recall, we're not looking inside of this tolerance block. But if I go to this tolerances tab down here below, this will give you a peek into kind of where these tolerances are coming from. So that plus or minus 10 thou, right? Based on 2 decimal points. In English, we're going to plus or minus 10 thou. Again, if the tolerance isn't on the print itself. We also support metric, as we showed, fractions, and angles. So good question, but it's how you have things set up. Part of these part categories. You can always edit after the fact as well. So if you wanted to, edit it, it would be, these are all open text fields. So it would just be right here. You could type in whatever tolerancing you'd want.
Okay, great. Thank you. The next question says, we currently manage gauges in Excel. Do we have to enter all of our gauges into HiQA manually?
No, gosh, no. So yeah, if I go back to our measurement gauges tab, you have the ability to export, or I mean, sorry, import. You have the ability to export, but also import your gauge list. By no means would we expect you to type all this information in. It's simple as you can define how the import works. If it is an undefined format, or you just import that list. I would say probably 8 to 9 out of every 10 customers we have are coming from doing things in Excel. So we're very familiar with that process, and um, bringing those documents into HiQA is very seamless, whether that's your gauge list or your reports that you have on Excel. So no, you do not have to enter that in.
Okay, perfect. The next question says, can we modify the inspection plans?
Yep. Yep. 100%. Everything is, everything's just templatized. As part of implementation and onboarding, we'll bring your inspection plans into the system. Um, you can still see my screen, right, Lisa? Okay.
Yes.
Um, and then you also have a report designer. Um, you have access to that as well. Let me just click inspection plan. But everything is templatized, right? As I said. So just to show you like a 10 sample inspection plan, for example. And that report designer that I mentioned, it's very, it looks just like Excel, right? Again, most of our customers are coming from Excel, so being able to design or edit your inspection plans, very, very easy. But this is what one other example could look like.
Okay. Let's see. Here's another question. It says, does the software work with handwritten drawings?
I guess you'd have to define what work means. Yes, it does work. There's no level of quality print that can't fully be completed inside of HiQA. Now, if it's a hand-drawn print that's been scanned in 10 times, there's just not going to be much resolution there for the OCR technology to recognize. But that's why we have those manual capabilities as well, where let's just click this scissors icon, pretend there was a hand-drawn dimension right here. You would just box select it. You can see what the system comes up with, but then always edit, right? It's a thread. And that's when you're just manually typing in that information. But once you do it once, it resides in the database. So if it's like a legacy part, for example, you have that part record completed, you only do that one time, then you just run multiple jobs up against that part record. So again, blanket statement doesn't matter the quality of drawing. You're going to be able to fully complete everything you need inside of HiQA. It's just how much automation can we do if it's a hand drawn. So like I said, as a next step, we're happy to show everybody their own prints inside the system. in much greater detail, quite frankly, than what you saw here today.
Okay, great. Thank you. So there's also some chatting happening behind the scenes here with questions. Another person typed in, do you help with validating the software per our ISO 13485 requirements? And Effie happened to respond with, yes, we have a compliance support document, including a detailed matrix of the ISO and also the 21 CFR Part 11. We have a lot of experience working successfully with medical manufacturers. So if you have anything else to add to that, but I just wanted to have the others hear that question and response as well.
Yeah, no, I think just to kind of reiterate a lot of what was said in the chat is, yeah, we have a lot of experience specifically in medical and aerospace and defense, and those validations that you're often required to, we we're familiar, and we can certainly help you out there. So that's a good question though.
Absolutely. Okay, here's one final question that we can conclude with. It says, how long does it take to get up and running with the HiQA software?
Yeah. I would say it depends on the level of plan, for one. If you just have one or two people that is looking to balloon and create inspection plans, I mean, 2 days. Every plan has a dedicated amount of what we call professional service hours. Those hours are determined by what's included in your plan, and they can also be allocated at or in a time frame that works for you. So the first thing we'll do is have a welcome call, align on timelines, who needs to be involved, and what you're hoping to accomplish, and then get that implementation scheduled. So um, we can move as fast as you want. Um, but the last thing we want to do is hold from, everybody, we got to make parts, right? So the implementation is geared to be very seamless, and smooth, right? So it's kind of a vague answer, but plans vary, thus implementation varies. We also do have a unlimited self-paced online academy that kind of walks you through your plan as well. So it's a very hands-on implementation. I'll just leave it with that. But yeah, it depends.
Okay, perfect. Also in the chat button, I just put a link there if this has perked your interest and you would like to have that one-on-one demonstration that Ryan mentioned earlier in the session, where we can use your parts, answer your specific questions. We are more than happy to do that at any time. Go ahead and fill out the form right there and we'll get right back to you and get that scheduled for you. As I mentioned at the beginning, also, we did record the session. So if you'd like to play it back, absorb the information a second time, or share it with the colleagues in your office, that's great too. I will be sending that out via email in the next few days. Thank you so much, Ryan. Thank you to the audience for joining us today. We hope you have a great day.
Yeah,
Thank you.
thanks everybody.